Greetings, this is Artie from Artifact Electronics. Today we're going to have a look at an Osborne 1, which supposedly is the first transportable computer, more commonly called a luggable computer, and see if we can get this thing to work. It's an okay shape, there's no physical damage, but it looks kind of ratty with discoloration and stuff all over, especially in the back. I mean, the side is completely yellowed, and the back is kind of interesting because it obviously is partially yellowed over here with a very sharp delineation. But then this thing is completely yellow. But that's because I think this is there to provide ventilation. If I can get it out, but this whole piece slips out. So it's probably open like this, or this. And there was something laying over here, covering it from the sun or whatever. And that's where we came up with this discoloration. Here's a computer in the ready-to-use position with the keyboard removed and this thing resting on the keyboard. The keyboard does show some moderate yellowing too, especially, you know, whatever's printed on the keys. And other than that, this is an Osborne 1A, which is the second generation, which was functionally equivalent to the original, but they redesigned the case on this. And people say it's really ugly, and I tend to agree, but the front face kind of looks neat on this. But yeah, jumping over it, the keyboard seems to work, which of course we won't find out till later. We got two floppies. And I don't know yet whether they're single or double density. A cinematic 5-inch black and white display, and various I/O ports, screen controls, and a big ass reset button right over here. This unit was sold as non-working. It doesn't power up. No lights, no hum, no buzzing, nothing. So we're going to have to take it apart. I already checked. There's a fuse accessible from the back. I looked at it and the fuse was good. So we're going to have to start taking this thing apart and disconnect the power supply from the motherboard and start out by seeing if we are getting any voltages out of the power supply. So the technical manual for this is available, and I'm actually following the instructions in the technical manual on how to disassemble this, starting with a bunch of screws in front, taking the front face plate off, and essentially putting it into its separating it into its components, and see what we can find. I'm not going to film individual screw removal and parts removal because it is rather well documented in the service manual. But if you do it on your own, take pictures, kind of sort your bolts into sequence in something like this, so later on you don't have to worry about which screws go where. And the screen is filthy on this thing. I don't see any burning, but it is dirty. Yeah, with the dirt gone, it doesn't look like it has any burning on it. So let's continue with taking the case off and continue our diagnosis. Removing the screws from the case yields two case halves that lift off. What you're looking at now is the back of the unit upside down. You can see the logic board over here and power supply. Disk drive 1, disk drive 2 hidden back here, and this is the monitor. So we're going to have to do a little bit more disassembly here to get the power supply out. And yeah, there's a few cables running to the motherboard, which I'll show you later, and disconnecting those will let me remove this and get to the power supply. Power supply is a switcher, and I don't think it's a custom part. It looks like an off-the-shelf Aztec supply. I poked around a little bit and looked at the schematics. So this thing outputs 5 volts and 12 volts, and it has a temperature switch over here, which is mounted inside the case. So I guess if the inside of the case reaches a certain temperature, this disconnects, and the AC is running through here, and it just cuts power to the system. I've already measured it in its rest state, and it's cold. It's supposed to be closed electrically, and it is, so that's not the problem. There's another fuse over here that's also good. The thing to note is it's got the notorious REFA capacitors, which we kind of met in one of the Radio Shack TRS-80 Model 3s I did, because things were working and after a while one of them just blew up. Here's 1, 2, and 3. They're in good shape, they're not cracked or anything. But the MO on these is, especially after sitting for a while, the power supply may work, but once it's drawing, once you have a load connected to it and it sits there for a while, these things have the nasty habit of blowing up, creating a lot of smoke and being unpleasant in general. But let's see, before we replace those, I guess deep down I'm hoping one of them will blow up, but I want to see if this thing disconnected without a load, what it outputs. And I looked at the schematics. They were a little bit unclear on it, but I used the power connector cable, this guy, which goes in here, and then this end plugs into the motherboard, and I measured it, and it looks like the center pin, not the center pin, the second pin over here is ground, and one of these is 5 and one of these is 12, and they're all wired in parallel. So let's measure these things without a load attached, power it up. I do have the power switch over here, and see if this is outputting anything. Even though this has probably been turned on several times by the seller already, I'm still going to hook it up to the variac and bring up the variac slowly, and I got the leads connected. I'm still not sure if that's 5 or 12 volts, but let's see what happens. So power is on, and coming up slowly. We have 25 volts AC going in. I know people always complain, they say I have to do this over several hours, but knowing that this was already turned on several times, I'm not going to go the real slow route. Just watch for things blowing up, weird noises, and that sort of stuff. So now we hit 50 volts AC input. The switcher still hasn't kicked in. Oh, there you go. We are at about, what, 60? We're about 65 volts, and the switcher kicked in. Even though there's no load on it, it is outputting 5 volts on that terminal. And let's get this up to the full 120. And see how it performs. We're at 118 now, and it's outputting 5.2 volts, which should be fine. And again, there's no load. I don't know what's going to happen when I hook this up to the PCB, but looks like we got a good 5 volts. Let's turn it off and see if we're getting 12 volts. Coming out of here. And all the others should reflect this too. But yeah, here we go. So now we should be seeing 12 volts. And we are. There's no clicking noises. It's not trying to restart or anything. It looks like without a load it's working correctly. I'm going to measure the other outputs off camera, but they're all wired together. So it should be the same. And it looks like the power supply is okay. None of these caps have blown up yet, but you know, we can always hope, right? All right, so on we go to the motherboard. So here's the motherboard. I inspected it. I don't see anything untoward on it. The one thing is this board indicates that the drives are double density. The original didn't have this daughter board on it, and that's nice. So we got the double density drives. Problem is this kind of makes access to some of the DRAMs underneath here impossible while it's running, of course. It's got 64K of DRAM over here, total of what, 48, 64 16K DRAMs here, and those are known to go bad, but we're just gotta wait and see. The entire BIOS is contained in here. We got 2 parallel interface adapters. We got an NEC second source of a Z80. I think this runs at 2.5 megs. And a second source of a 1793 floppy disk controller, which, yep, looks like when this board was put in, it needed some extra lines coming out of there. And the other stuff is basically your nickel and dime TTL stuff. It's got a buzzer here and screen controls and the connectors that peek out the front panel. Keyboard, serial, and parallel, I think. Yeah, and that pretty much sums things up of the initial look at the PCB. I gave the board a close visual inspection, component side first. Nothing really jumped out at me. Did a few measurements, but again, nothing. Caps seem to look okay. So then I looked at the underside and I saw this. And what are we looking at? This is the power input here. We got 2 separate feeds coming in with 5 and 12 volts. And they're actually separated. So the 5 volts on this side is not connected to the 5 volts on this side. Neither is the 12. The grounds are connected together. But it looks like a field mod or an after manufacturing mod they did here and put these bypass caps on here. These bypass caps are tantalum caps, and tantalum caps work really well when they're new, but they tend to short. When they fail, they usually short, and unlike other caps. And let's have a look at these. That's my first suspicion. I got the meter set to continuity test. And we have ground here. Let's see, yeah. We have ground here, and we're going to the 12 and to the 5. And that little beep just meant that there was capacitors charging. So we're good. Let's do this again because the meter just turned off. Come on. So it's showing about 600 ohms here and about 800 ohms here, and that's okay. So now on this side we go from ground to 12. I think it's 12 or 5, showing about 1K, and it's showing a dead short over here. So whatever rail this is dead shorted. Now let's just hope that it's actually this cap and not the rail itself, because if it's the cap, then we may have found the main problem of why it's not booting up. So let's see if we can get this cap out and measure it while disconnected. Okay. See if the iron's hot yet. And that's been disconnected. So what does it say? Unfortunately, it's not that cap. It is that rail that is shorted. So we're going to have to do a little bit more investigating here. So I followed the rail, and it comes out on the component side over here. It's the only place where it comes out and then gets distributed from here. And there's another tantalum cap sitting on here. So, checking this one also measures shorted. So we have a second chance here. Let's see if we can get it out. And hopefully the short will stay with the cap. And let's see, what should we measure? The cap or the rail? The cap. The cap's shorted. The rail's good, showing 600 ohms. Alright. So, I think this warrants putting things kind of partially together again, now that power will probably get to the board, and see if that makes any difference. I took out the bad boy. Haven't replaced it yet. It's a bypass cap, so good enough for a test, but I did reconnect the first one I had taken out that I was suspecting, and I think it's time to power things up and see what, if anything, may happen. We're hooked up to power, and off we go. Okay, it beeped. The drive came on briefly, but that's about it. I can't really hear anything coming out of the monitor, so what do you say? Insert disk in drive A and press enter. All right. Oh, the machine's sitting up and upside down, but it's got a nice picture, and I don't know if it's going to read it upside down, but let's try it anyway. So I kind of put things back together. I didn't want to risk shorting something and blowing this thing up, and let's see Yeah, we need a disk. Now, when I got this, there was a floppy disk in each drive, basically used as, I guess, head protectors. And looking very closely at the labels, let's see, one of them says Super Base 2 Disk 1, and the other one says Super Calc 2 Disk 2. I don't know if they have CPM, if these have CPM on them or not, and since they were used as head protectors, prognosis for these working is not very good, but let's see what happens. Well, it's still beeped. And it still boots up. And it still says insert disk and drive A and press return. Man, it's a really, really, really small screen. But this is drive A. The keyboard may not be working. But let's try. Hit the reset button. Oh, I guess it does work. Of course, we're getting an endless boot error message right now. Which really isn't that surprising. Let's try the other disk. But I'm not holding my breath. Same thing. It's erroring out. So guess what? I have to go and look and see if I can find some disk images for the Osborne and make some fresh disks for him. It'll take a while, but we'll see you back soon. Now, in order to make disks, floppy disks, real ones, you need an old PC. Well, first of all, you need to find some images online, but some kind souls have posted them, and there's the set of CPM disks that came with the Osborne were there for download. They were in a virtual disk format called IMD, which uses a program called Image Disk to write these. Now the PC has got to be pretty old, so the BIOS supports 5 1/4 inch disks properly. And I found that the newer the machines have gotten. I mean, I went to my computer graveyard and put together this machine. I think it's a P2, and once it got put together, I did take the floppy drive, 5 1/4 inch floppy drive, out of my old 8088 compatible, because this is a true 360K drive. And I have a machine, but 2 really loud fans, but these are supposedly able to take the IMD, the image disk files that I downloaded, and write them to a real floppy. Now, things weren't that easy. The machine is so old, I could not get USB to run on it properly. So, I mean, I had to transfer the IMD images either through floppy, but what I found was a lot easier was I just burned the CD with all the stuff I downloaded, and the CD drive in this worked, and I was able to transfer all the files over to the hard disk and then run image disk. Once you run image disk, you get this nice text display, and it's really not that difficult. So You obviously put a disk in the drive, and from the main menu you select write disk from file, and this is the directory that has a bunch of double density images. So let's say we want to make a CPM disk. We go ahead and select that file, select it, and off we go. And it's going to sit here for a while, writing the disk. So it successfully wrote the disk, and that was nice. But I ran into another nasty problem. Remember how the screen was flickering previously when I put in the 2 floppies that came with the system? Well, that screen flicker was a big problem, because I stood here and I probed and tried to find out why it was flickering. Did we have a bad motherboard? Did we have a bad keyboard? Did we have, I don't know, bad something? And it made it really difficult, because I was able to load some disks, but you were basically getting garbage. It was like somebody was holding down keys, or a key, and it was just filling up the screen continuously, and you couldn't really do anything. Also keep in mind that this, on the Osborne, it has a virtual screen that's 132 columns wide. So if you're continuously hitting keys, it's putting that key on the screen, and then the whole screen scrolls left. And in short, it looked like it was loading the disks, but I couldn't test the disks. I couldn't do anything with them. So I embarked on a test of the keyboard to see if it was the keyboard or if it was the scanning circuitry. And basically, after disconnecting the keyboard, the flickering went away, which kind of told me that the problem lay in the keyboard. But that didn't do me any good, because with a disconnected keyboard I could obviously not do anything. So I checked out the keyboard, I probed it with a scope, because the keyboard has no smarts in it. It basically is 8 rows and 8 columns, and the rows get blipped from the computer, and if a key is down, closing the circuit, the columns return a low signal for an active key press. So after a lot of research, and unfortunately I did not film it, but I think you saw how the screen was flickering, and it was basically doing that, even though it looked like it was loading the disks, but it was just flickering. And I would hammer on keys, some keys would work, some wouldn't. But even if I hit a key and it would go to another menu option or something, the flickering would just make it impossible to do anything with it. So I did some further research on the keyboard, and if you can read that, the keyboard is an oak full travel membrane keyboard. That's not good. Membranes are notoriously difficult, if not impossible, to fix. And I did a lot of research I tested this thing a lot. I used the scope to test the lines, the scan lines coming in, what was going out, and all of that. And yes, there was a stuck key. It had me confused at first, because it was outputting a weird code on the screen. But after I refreshed my knowledge of CPM, it turned out that it was auto-repeating the escape key over and over and over again. And knowing that this was a membrane keyboard, and after yanking on the wires and everything, nothing changed. So we had a membrane problem. And that seemed to put the brakes on my efforts to get this thing fixed, because it sure looked like I was going to need a new keyboard. So with the membrane, since the keyboard wasn't working right, I proceeded to figure out a plan to pull the membrane apart and see if there was anything I could do to fix it. So we have the membrane here, the two layers of the membrane, and the keys pushing on it. And the way the keys are held in place is they're pushed through the metal panel, and then I guess the two pins that are on each key got melted down. So to remove a key, you would have to get rid of the melted portion of the key, pull it out, and then have a look at the membrane. So I was playing around with it. I had the computer running, and I was basically just showing escapes being typed over and over and over again. And again, sorry I didn't film that, but I was just trying to figure out why I was doing this. And so I started peeling up the corner of the membrane right over here, because the escape key's here, and fortunately it was at the corner, and maybe I could do something with it, open it up, clean it, or whatever. But as I slightly lifted this edge over here, I noticed that the auto repeat on the screen stopped. When I hit the escape key, I would properly get the code I was seeing repeated forever on the screen, but only one. And I tested the rest of the keyboard, and everything else seemed to work. So I got real lucky. I don't know how long this fix is going to last, or what exactly was happening. Essentially, separating the membranes right under the bad key briefly seemed to fix the problem. I stuck it down again because I had removed the membrane very slightly, so it's not sticking up, and I don't need tape to hold it in place. It's self-stick, and it went right back into place. So what better way to test this than to take the disc we just made and see what the computer has to say. So let's see if I can stick my hand in the AC outlet. So it doesn't auto boot. It does put on the insert disc. Let me see. It looks real nice. Or did you see that? So when I press a key, this is what it was doing. See, I can even simulate that. Any key you press is, I guess somebody was lazy writing this part of the code, but any key you press, it tries to do something, looks it up on a table and goes, oh, this key doesn't do anything, so it redraws the screen. Let me try to adjust this so the camera shows it a little better. Is that a little better? See, every time I touch the keyboard, it does that. So I can even demonstrate what it was doing before by simply holding the escape key. But right now, we have the disk in there. I hit the return key. And lo and behold, it's loading CPM and help. So we can escape out of this now, and we will get to the CPM command prompt. Lean down a little bit here so you can see that. But what was happening before, this is what was happening. Forever and ever and ever, without me pushing any key. And then see, it eventually hits column 132, wraps over to the next column, and it just goes on forever and ever. And I jiggled the wires, I tried everything, and nothing would fix it. So yes, I think I got pretty damn lucky with my attempt at fix. That was just a matter of briefly separating the membrane for the escape key and then putting it back down. And see, I can play with it now. Well, putting pressure on it, playing with the wires, it's perfectly good. So not only did we get some disks going, but it looks like the keyboard also got fixed. So this machine's pretty functional right now. So I reassembled the keyboard to see if she'd still work properly, and I stuffed in a disk that is going to be really, really helpful to finish up this project. So let's see what that is. Yeah, still coming up. And it shows you kind of the logo is a little off, but what you're looking at here, I don't know how well you can or can't see this, but this is the factory diagnostic discs. That pretty much lets you test everything in the system. So, you know, things like, where was it? There was a ROM test here, which it passed. Keyboard works great. The escape key is still functional. And I'm going to quit while I'm ahead. Well, not quit forever, but quit for now. I think we got the machine repaired. Well, we still, you know, we still have to test the disk drives. I mean, drive A seems to work, but I don't know about drive B. Another thing is that the screen is, I think the image is a little bit too big. It's too close to the top and bottom and left and right, so we're going to have to take it apart again and see if we can adjust the screen a little bit, and then test different parts of the machine to see how healthy it really is. But thanks for keeping me company on this. I had a bad moment there with the keyboard, because that would have meant I wouldn't be able to fix this machine as is. I mean, I'd have to get another keyboard, and you know, that kind of takes all the fun out of it, because the idea is, hey, you get a machine, it's unknown, but you fix it. And if the membrane hadn't been such an easy fix, and I still don't know exactly how I did it, but I did it and it worked, so we can continue on our way and test the other components in this thing. And we're also going to have to deal with the appearance of the case. So I hope you liked this. A thumbs up would be much appreciated. Make sure to subscribe so you will get timely notifications of when the next episode is going to come out. And leave me a comment about this. This screen is incredibly small, but this is definitely a piece of computing history. The first portable computer. See you next time.